Imagine you've been using the AI coding assistant for 3 months. Every day you ask the questions, give it feedback, teach it your preferences. After 90 days, what does its memory look like? The answer is bloated, noisy mess. Thousands of entries, most of them irrelevant. That's the first problem, too bloated. The second problem, unbounded growth. Traditional memory systems have no natural limit. Every token is stored equally, no judgment, no prioritization. The vector index grows forever. Retrieval latency climbs. The signal-to-noise ratio collapses. You end up with a database that contains everything but remembers nothing useful. It's like a library that never throws away a single book. Eventually, you can't find anything. These two problems, bloat and unbounded growth, come from the same root cause, passive storage. The agent doesn't decide what to remember. Everything just gets stored automatically. But a human memory doesn't work that way. We curate, we forget, we prioritize, and that's exactly the paradigm shift Hermes introduces. Hermes doesn't use a vector database. It uses 2 plain markdown files. Let me show you where they live. On disks at /.hermes/memory/directory, you'll find these 2 markdown files, and you can also configure these 2 markdown files here in this file. And so the limit for the memory.md is 2200 and limit for the user.md is 1375. So what are these 2 markdown files? You can think of the users.md as the agent's knowledge about the user. What does it mean? Think of it as the agent's knowledge. They want to know the preference, what users like, what's users' behavior, sort of like episodic memory. And memory.md is agent's knowledge about the world. So one is what agent knows about you, one is what agent knows about the project, the environment, and everything. So, now here's the critical question. Why 2 files instead of 1? Why separate world knowledge from user knowledge? Just think about it. Here's the answer. When the agent compresses a session, it needs to decide what's worth keeping. If everything is in one bucket, it's hard to prioritize. User.md has a smaller limit because user preferences are more precious. They deserve more careful curation. This separation forces the model to think, is this a fact about the project or a fact about the user? That distinction leads us directly to its core principle. Let's take a look at its first principle. System prompt stability doesn't mean runtime memory mutability. They must be separated. This is actually the most elegant decision in Hermes. And it's not obvious at first glance, to be honest. The memory store class maintains 2 parallel states. First, that is a system prompt snapshot that is frozen at load time and is never muted mid-session. Second, there are memory entries and user entries. They are live state, mutated by tool calls, and persisted to disk immediately. The system prompt sees the frozen snapshot. The tool responses see the live state, so they are decoupled. But why does this matter? Before answering this question, I recommend everybody to have a read about this article and come back. It's all about large language model prefix caching. Every time your system prompt changes, the provider invalidates the cache. That's very expensive, both in latency and cost. By freezing the snapshot at load time, Hermes guarantees the system prompt never changes mid-session. The large language model always sees the same prefix. The cache always stays warm. Meanwhile, the live state can be modified freely by tool calls, adding, replacing, or removing entries. Now, let's talk about when memory gets written. Hermes doesn't save memories after every single message. That would be wasteful and noisy. Instead, It uses a flush mechanism triggered at 3 specific moments. First, before context compression. That means when the conversation is about to summarize, it will flush. Second, before session reset. So when the user types in the command /reset, it will flush. And third, before client access, that is when you shut down the agent. There's also a minimum turn threshold by default. The agent waits at least 6 user turns before the first flush. This actually prevents premature memory writing from trivial conversations. Let's take a look at the flush prompt. So here's the prompt declared in the source code. So the first sentence is the session is being compressed. It actually creates urgency. It's telling large language model to act in now. The second sentence is save anything worth remembering. It actually guides value judgment. It means not everything matters, only focus on the important things. So what comes next are 3 different things. The most important one is prioritize user preferences. The second is corrections. That means how user corrected the agent. And the third one is recurring patterns. That is the repeated behaviors of users. So the least important is task-specific details. So it's basically telling the large language model that don't care about details, care about what users like, what users behave, and what their recurring patterns are. Now let's step back. What can we learn from Hermes' approach to persistent memory? First, bounded memory is a feature, not a limitation. The 2,200 character limit isn't a compromise. It's a design tool that forces prioritization. Second, active curation beats passive storage. Memory isn't something that happens to your agent. It's not a byproduct. It's something your agent does. Actually, carefully does. Third, separate concerns. World knowledge, that is memory.md, and user knowledge, that is user.md, have different budgets and different purposes. Just don't mix them. Fourth, stability and mutability must be decoupled. The system prompt is not the place for runtime changes. Now, think about the memory system you are building, or the one you're using right now. Ask yourself, is it bounded or bloated? Does it actively curate or passively store? Does it separate system prompt stability from runtime mutations? If the answer to any of this is no, you now have concrete blueprint for improvement. The Hermes codebase is open source, go read it. The architecture is deliberately minimal. A few hundred lines of Python tools /memory tool Python is designed to be understood, not just be used.